from page number 241, and the heading is a difference between saturated organic compounds and unsaturated organic compounds. So first point, saturated organic compounds contain carbon atoms joined by a single covalent bond with each other, whereas in unsaturated hydrocarbons, double covalent bonds and triple covalent bonds can be present. So presence of double and triple covalent bonds, double CC covalent bond and triple CC covalent bond is compulsory in unsaturated hydrocarbons. Then all the four valencies of each carbon atom are satisfied by hydrogen atoms forming a single covalent bonds. But in the case of unsaturated, the valencies of at least two carbon atoms are not fully satisfied by hydrogen atoms, and these are satisfied by with the help of double or triple bond. Then the non-availability of electrons in the single covalent bond makes them. That is why these compounds, which are also known as saturated compounds, are less reactive and therefore undergo characteristic substitution reactions. Okay, students. So substitution reactions are the reactions in which an atom or group of atom of the base compound is displaced by incoming reagent, and due to Y, the formation of product plus byproduct. Okay, so as you can see here in this reaction, C has displaced this B from the base compound and the product AC is formed. So replacement of B by C, this is known as this substitution, and the product which is formed here due to the substitution is known as substituted product. Okay, so saturated compounds give some characteristic substitution reactions due to the non-availability of electrons. And in the case of unsaturated hydrocarbons, the availability of electrons is there in the form of double or triple bond, makes them more reactive and therefore undergo characteristic addition reactions. Okay, so doubly or triply bonded compounds are undergo characteristic addition reaction. Okay, so in such reactions, addition product is formed. Suppose AB is an unsaturated compound which is having double bond between A and B, and C and D, this is the reagent which is going to add with this. Then what will happen? This CD will be added with A and B. So let C is added with A and D is added with B. So the addition product is formed and no byproduct will be formed in this reaction. In addition reaction, only one addition product is formed. Next point, characteristic reactions. Substitution reactions are the characteristic reactions involving direct displacement or substitution of an atom or group of atoms by another atom or group. Example in alkanes, replacement of H by Cl or Br atoms. Here, addition reactions involving addition of an attacking reagent like hydrogen, halogen, etc. across the double or triple bond, as I shown here, bond of an unsaturated compound to yield a saturated product. Next page. Introduction, alkane, and in alkanes you are having two different alkanes in your syllabus, methane and ethane. The molecular formula of methane is CH4 and of ethane is C2H6. Okay students, this is the electron dot structure of methane and ethane. Electron dot structure, this methane and this is ethane. So in methane, 4 valence electron of carbon, and these dots are representing 1 valence electron of each hydrogen. So this hydrogen and carbon sharing a pair of electron and forming 1 covalent bond here in this way. And same way in ethane, 2 carbon atoms are sharing 1 electron by each, and rest 3 electrons of the carbon are shared by 1 hydrogen each, and that is why formation of ethane is taking place. So in methane, carbon has 4 electrons in the outermost shell, which are shared with 4 electrons of 4 hydrogen atoms. That is 1 carbon atom joined to 4 hydrogen atoms by single covalent bonds. In the case of ethane, 2 carbon and 6 hydrogen atoms in ethane. The 2 carbons are joined by a single covalent bond, as you can see here, and the 3 remaining valencies of each carbon atom are taken by 3 hydrogen atoms, forming single covalent bonds. The next page, methane and ethane preparation. Lab preparation from sodium ethanoate. Okay, so this is the formula of sodium ethanoate, and when this heated with soda lime, heated with soda lime, then formation of methane is taking place, and CO2 is evolved in the form of sodium carbonate. Okay, for the preparation of ethane, we are using in this reaction sodium propanoate with soda lime, and heating ethane is formed and CO2 is evolved in the form of Na2CO3. So due to the evolution of CO2 in the form of Na2CO3, these reactions are known as decarboxylation reactions. Okay, so as you can see here, that in sodium acetate there are total 2 carbons are present, but 1 carbon alkane is formed. Same way in sodium propionate, 3 carbons are present, but 2 carbon alkane is formed. 1 carbon which is present in carboxylic group is coming out in the form of CO3 to form sodium carbonate. Okay dear. Now reactants, sodium acetate or sodium propionate and soda lime are the reactant. So mixture of sodium hydroxide and lime, which is also known as quicklime, is known as soda lime. Soda lime is a mixture of sodium hydroxide and calcium oxide. Procedure: the reactants are heated in a hard glass test tube. As you can see here, soda lime is used in preference to NaOH. Why? Because it is not deliquescent and does not attack glass. Okay. Product: methane or ethane is formed respectively here, and which is collected by downward displacement of water in the gas jet. Decarboxylation: elimination of a molecule of CO2 from a carboxylic acid is known as decarboxylation. Okay, here in this reaction CO2 is evolved. The next preparation from alkyl halides. So when alkyl halides like iodomethane is reduced in the presence of zinc copper couple and alcohol, Okay, so these two will produce nascent hydrogen after reaction, and this nascent hydrogen will reduce methyl iodide in the form of methane. Okay, hydrogen iodide is formed as a byproduct. Bromoethane is reduced in same condition for the formation of ethane. Okay, reactants: methyl iodide or ethyl bromide and zinc copper couple in alcohol, which evolves nascent hydrogen. Procedure: alkyl halides and alcohol mixture is added to zinc copper couple kept in a conical flask. The alkyl halide is reduced with nascent H. Collection: the alkane is collected again by downward displacement of water as collected here. Then last, Wood's reaction is given here. So when any alkyl halide, its two molecules of alkyl halides are reacted with sodium metal in the presence of ether, then related ethane is formed. This formation is known as Wood's reaction. So it is not suitable for preparation of alkanes with odd number of carbon like methane, propane, etc. Okay, so Wood's reaction can be used for the preparation of even number carbon only. Then properties of methane and ethane. Physical properties: nature, color and odor. Gas at ordinary temperatures, colorless and odorless. Solubility: almost insoluble in water but soluble in organic solvents. Melting and boiling point is given here. Now, vapor densities of methane and ethane. So you all know that vapor density of any compound is half of its molecular weight. So molecular weight of methane is 16, 12 plus 1 into 4, and of ethane is 12 into 2 plus 6. Okay, so the molecular mass of methane is 16 and of ethane is 30. So when we divide these molecular masses by 2, then we will get vapor density of related alkane. Okay, page chemical properties of methane and ethane. So first is substitution reactions. So these are the reactions in which hydrogen atom or atoms are displaced by incoming a reagent. Such reactions of alkanes are known as substitution reactions. For example, first substitution is substitution with chlorine. So methane is reacting with chlorine in the presence of diffuse sunlight or on heating, forming related compound plus bicompound. So the compound which is formed here is having one hydrogen atom less than related alkane. Okay, so this reaction is taking place in the form of chain reaction, and in each step one hydrogen atom of this related methane structure is get displaced by halogen atom, and the reaction completed only at that condition when all the hydrogen atoms of methane or alkane get displaced by halogens. Okay, so as you can see here, 4 hydrogens was present initially with methane, and at last we got carbon tetrachloride which is not having any hydrogen atom. Okay, so methane with chlorine in first step forming methyl chloride plus HCl. In second step, this methyl chloride is reacting with another molecule of chlorine forming dichloromethane, and this again is reacting with chlorine forming trichloromethane, and this trichloromethane, which is also known as chloroform, is reacting further with chlorine, forming tetrachloromethane or carbon tetrachloride. Okay, students. So chlorination is the substitution of hydrogen atoms of methane by chlorine atoms. Conditions: diffuse sunlight, ultraviolet light, or high temperatures. Substitution products are monochloromethane, dichloromethane, trichloromethane, and tetrachloromethane. Same way, ethane is showing substitution or chlorination with chlorine. So in this, all the 6 hydrogen atoms of the ethane get removed by chlorine atom at last. Okay, so each step with removal of 1 hydrogen atom and addition of 1 chlorine atom. Okay, so chlorination, substitution of hydrogen atoms of ethane by chlorine atoms, and the product which are formed: monochloroethane, dichloroethane, trichloroethane, and so on. The products can be separated by fractional distillation due to difference in boiling points. Okay, students. The next chemical property is oxidation. And in oxidation, complete oxidation or combustion. So all the organic compounds in the excess presence of oxygen gas or air, when combust, they form CO2 and H2O, and always this combustion reaction is exothermic in nature. Okay, students. So all the organic compound, here methane or ethane is given, but you can take any of organic compound, and that organic compound under complete combustion condition will form CO2 and H2O. And always combustion reaction is a exothermic reaction. Okay, so in excess air or oxygen, methane or ethane burns with a blue or non-luminous flame. Products are CO2 and water. Then next heading is uses of methane and ethane. So illuminant and domestic fuel in the form of natural gas or gobar gas, in manufacture of chemicals like chloroform, carbon black, formaldehyde, methanol, ethanol, etc. So out of these compounds, the chloroform is used as solvent, waxes, and then also as anesthesia. Carbon black is used as pigment in shoe polishes and printers' ink. Formaldehyde as an antiseptic, preservative for biological specimens. Methanol, solvents for varnishes, antifreeze for automobile. Then ethanol is a very good solvent for resins, a low freezing a liquid in thermometers. Okay, students, thank you.